introduce you another counter that some of Allen Bradley's PLC, such as SLC 500 and MicroLogix, they do have it. This particular counter is called high speed counter, and it does have an instruction. The counter is shown in the PLC instructions by HSC, and it is built into your processor to count the pulses at higher range up to 8 kilohertz. Now, what is an HSC? HSC is basically similar to CTU, so both of them are counter up. So both HSC and CTU are up counter. Don't forget that. And they count true, false to true transitions, but there is a difference. So if you have a CTU, what will happen is that the CTU will count all the transition from false to zero in its input rung. So let's assume that this is your CTU. So this CTU will count these transitions. So here it can see 2 transitions, so your accumulator value should be equal to 2. But the difference that we do have between CTU and HSC is that if you have HSC connected to an input rung like this, then it doesn't count the transition of the input rung. It counts the transition at this physical terminal, I column 0/0. So terminal number 0 of your input module. So it will count all the transition at a rate up to 8 kilohertz whenever the input rung is true. So if you have true here, so during this time, it can count the transition at this terminal. If it is false, it doesn't count here. That's the difference between CTU and HSC. And HSC, because it is a physical counter that is added to some Allen Bradley's PLC, it can operate asynchronously no matter what is the scan cycle. And the last difference between HSC and CTU is that CTU is a retentive time counter. So don't forget that CTU is retentive. But HSC is non-retentive, which means that if PLC power is lost, then the values that you have in this particular counter will be reset to 0. So just to remind you, because we are using terminal 0 for HSC, so I 0/0, then the only counter number that we are allowed to have for HSC is going to be C50. And the last thing I want to tell you here about high-speed counter is that we are only allowed to have one high-speed counter in our program, and that is located in C50. Next part is about reset instruction. As we know, counters are retentive instruction. So it means that they won't reset back to 0, or in another word, the accumulator won't reset back to 0 based on input logic. So in order to reset the accumulator value of a counter, we need to use a reset instruction. The reset instruction will set the accumulator value to 0, and it needs to have an address. So for example, if you want to reset the accumulator value of a particular counter, you need to provide the address on top of reset instruction. So for example, let's assume that we want to reset the accumulator value of C53. So I need to provide the address on top of instruction, and then I have to use an input logic. So this can be connected to a sensor, it can be connected to a switch. And based on that, I can reset the accumulator value of my counter. Now remember that the reset instruction releases the counter instruction to start counting again when the reset instruction is false. It means that if you have a signal like this, so while the signal is true, your accumulator value remains 0 and your counter will remain disabled. Now, if you want to reset your accumulator value and right away start counting again, the signal that you need for your input rung is something like this. So you need a pulse to reset your accumulator value and then right away go back to 0, which basically means your counter is enabled again and it can count and increment. So a signal like this will reset your accumulator value, but it doesn't keep it disabled. It will let the accumulator to quickly go back to the process of counting and accumulating the counter value. We'll